Hi there. So I'm going to talk right now about section 1.4, which is kind of a continuation of what we were doing in section 1.3 actually. Okay, remember 1.3 was on linear functions, and I actually got into this in 1.3, but this is technically 1.4. It's formulas for linear functions. So what I'm going to do is I'm going to remind us of a couple formulas that we saw, and we're going to play around with them. Okay, and then we're going to expand and do some more examples. Okay, so what should you recall? Well, you should recall that in order to find the slope of a line between 2 points, it's the change in y values over the change in x values. Another thing you should recall is that we have y equals mx plus b. This is the equation of a line in what we call slope-intercept form, precisely because the m is the slope and the b is our y-intercept. Okay, another form we saw to find the equation of a line is y minus y1 equals m times x minus x1. You can use either one of these to find the equation of a line. And again, as I said to you in the last section, I don't care which method you use. You got to use whatever jives better in your brain. Okay? This is called the point slope formula. Okay? I will tell you that once you find the equation of a line, more often than not, I'm going to actually ask you to solve it for y. Now, there's one other form for a line, and I'm going to write it in red simply because I never use it. This is called standard form. And what that looks like is a times x plus b times y plus c equals 0. Okay? The point is this. Essentially, you're going to get the equation of a line, but it's considered to be in standard form if everything is on one side of the equal sign. Okay? And you have a 0 on the other side. This is not a useful form. Okay? The most useful form to see a line is, when it's solved, is to have it in this slope-intercept form. Why? Because when you have y alone on one side, you can read off your slope and you can read off your y-intercept. That's what gives you the most information. Now, another comment that I want to make to you about lines is we call lines essentially first-degree functions. In other words, the highest exponent on our x is a 1. Okay? I'm just planting that seed because we're going to go into higher degree functions later on in this course. Okay? So, aside from those, I want to define one more term to you. And then what we're going to do is find a bunch of equations of lines, and we'll play around with graphing lines. And then we're going to get into horizontal and vertical and parallel and perpendicular lines. Okay, prior to doing that, I want to redefine what an x-intercept is and what a y-intercept is. In general, the x-intercept is where the graph either touches or crosses the x-axis. Now, we did speak of this before, and again, I mean, we could say, well, right here is our x-intercept, for example, with this graph. Well, do you all agree that wherever we are on our x-axis, well, that can take on infinitely many values. However, we haven't moved up or down. So no matter where we are on our x-axis, y is always 0. So to be pragmatic, we could say to find it, what we do is set y equal to 0 and solve for x. The important thing to note at this point with an x-intercept is there's some value of x and y is always 0. In a similar manner, we have our y-intercept, and that's where the graph either touches or crosses our y-axis. This would be our y-intercept on this line, for example. And again, along our y-axis, well, we can take on infinitely many values. However, notice we don't move to the right or to the left. In other words, our x is always equal to 0. So in general, to find it, what you would do is set x equal to 0 and solve for y. And the key thing to remember, a y-intercept is always 0 comma something. Okay? These are super important. So let's find the equation of a few different lines right now. Okay? So the first example that I'm going to do is we are going to find the equation of the line. Let us pretend that we have a slope, oh my gosh, equal to 3 and a y-intercept equal to 8. All right, you guys, there is no work to do here. This is beautiful, okay? And you want to recognize such a thing. Remember, when a line is written in the form y equals mx plus b, what is your m? Your slope. Oh, cool, we're given that. And b is your y-intercept. Done. This is as nice as it can get. Okay, let's get something a little more involved. What if now I tell you that we have a slope of -4 and an x-intercept of 7? Now, I will grant you, at this point, we can certainly say y is equal to -4x plus b. Why, you may ask? Because, remember, the number in front of x is your slope. Now, because we already have it written out this much, I'm going to use this equation to find my line. Okay? Notice, we're given that our x-intercept is 7. Now, if we're going to find our value of b, we can't just plug in x equals 7. We have to plug this in as an ordered pair. So, how would we write an x-intercept of 7 as an ordered pair? It would be 7, 0. Okay? So, what I'm going to do is say, well, y is 0 when x is 7. Well, I get 0 is -28 plus b, so I get b to be 28. I'm not done, okay? If you're asked to find the equation of a line, you actually have to write the line out. So we have -4x plus 28. All right, now let's do this one. What if we want to find the equation of the line that has an x-intercept of 3 and a y-intercept of -5? Okay, again, yes, we are given our b value. We know we have y equals mx minus 5. That's our y-intercept. Well, we also have another ordered pair. If it's an x-intercept of 3, then we know it goes through the ordered pair 3, 0. And now we can do again what we just did. We can plug in y is 0. Let me write this out in order. We don't know our m. We need to find that. But we have x is 3 and then minus 5. So I would write this as 3m minus 5. And now we need to solve for m. Well, what would we do first? We'd scoot this guy over, but equations are like kids. Whatever you do to one side, you do to the other. So we add 5 to both sides and we get 5 is 3m. How do you undo multiplication? Division. So to get m alone, we would divide both sides by 3. So our equation is y equals 5/3 x minus 5. All right. Well, I just got this great idea, just for the fun of it. Why don't we graph that line? Okay? If I asked you to graph y equals 5/3 x minus 5, okay, how would we do this? Again, you always start at a point that's given, okay? You start here. We are given that the graph crosses our y-axis at -5. Okay, so all I did first is I plotted my point. Now I use my notion of slope. 5/3. Remember, your slope is rise over run. Since it's positive, we'll literally rise. If you have a negative slope, you would just go down. But what this says is go up 5 and over 3. 1, 2, 3, 4, 5, and then over 3. And then you play connect the dots. Now, we didn't have to do it this way. We could have just taken the 2 ordered pairs we were given and play connect the dots. And notice this actually corresponds to both ordered pairs that we had. All right. Let's find the equation of this line. What if I say that f of -2 is 7 and f of 3 is -3? And we want to find the formula for the line that goes through those points. Well, in order to find the equation of a line, at the very least, we need 2 ordered pairs. I picked this example because the ordered pairs aren't explicitly given. However, we are given the information. Remember, the number that goes in here is replacing our x. This is our input, and that's our output. I'm just trying to reinforce our function notation. So, my first statement tells me your corresponding ordered pair is -2, 7. And my second ordered pair is 3, -3. Okay, now I can't use y equals mx plus b, and I can't use the y minus y1 equals m times x minus x1 until I find my slope. Either way, I gotta find my slope. So, let's do it. The slope is the change in our y value, so -3 minus 7, over the change in the x values, so 3 minus a -2. Oh, nice. Okay, -3 minus 7 is a -10. 3 minus a -2, well remember minus a negative is plus a positive. We get 5, so our slope is -2. Awesome. Okay, now let's find the equation of our line. Well, we can use the y equals mx plus b, or we can use the y minus y1 equals m times x minus x1. For this one example, I will go through both ways. Okay? So, Using the y minus y1 equals m times x minus x1. Remember, you plug an ordered pair in for x1, y1, and then you plug in your slope. Again, it doesn't matter which ordered pair you use. You pick whichever jives better in your brain. Okay? I'm going to use 3, -3 just because it's closer, and that's about as good of a reason as I can think of. So y minus my y value equals m, which is -2, times x minus my x value. All right. Remember, minus a negative is the same as plus a positive, and we can distribute, so we get -2x plus 6. And now when all is said and done, we can move our 3 over, and we get y is -2x plus 3. And there's our line. Okay, I promised you we would use y equals mx plus b in this example as well, just to show you get the same thing. I think you'll grant me that we've already gotten that our m is -2, so we'll plug that in. And now what we do is we plug in an ordered pair for x and y and solve for b. Just for the fun of it, why don't we plug in the other ordered pair? Okay, y is 7 when x is -2. So I get 7 is 4 plus b. If I scoot my 4 over, again I get b is 3. We're not done though, because now we got to write the equation of our line. We have our m and now we have our b. And come on, you have to admit that's really sweet. Okay? Now, why do I prefer doing this method, to be honest with you? Because once I plug everything in and get y all by his lonesome, I've got the equation of my line already right there. Okay? I know my slope is -2 and my y-intercept is 3. This one, you go through all the steps and procedures and you solve for b, but then you have to remember the next step of, oh yeah, I got to write what my line is. And I can sometimes space things out. So for myself, I always like to do this method. Okay? Now, because we have it here and we've got nice numbers, let's actually graph this. Again, we could just plot -2, 7 and 3, -2, or excuse me, and 3, -3 and play connect the dots. But let's actually use our slope and y-intercept. Okay? As I mentioned before, you start here. Start at your point. We cross our y-axis at 3. Now, why did I want to graph this? Because we have a negative slope. Okay? My slope is -2. The thing is, slope is rise over run, so I'm going to write that as -2 over 1. And then we have our nice little ditty that says -2 over 1 is rise over run. Okay? You got to find thrills where you can. So, a reasonable question to ask is, oh boy, what does it mean to rise a negative number? Precisely, use your intuition. Go down. So what this says is go down to, start at your point, go down to and over 1. And then play connect the dots. Okay, one more example that I'm going to do. What if I asked you, what is the slope and y-intercept of this line? And here we are. What if I have 2x plus 3y plus 40 equals 0? This is a line written in that standard form, okay? I'm not a fan of it. You can't read off anything here. So if you're given a line in standard form, in order to glean any information at all, what you should do is solve it for y. So, in other words, we can either move these two terms to the other side, or we could just move our y over. Okay? So, let's just scoot our 2x and 40 over. Do you agree we get 3y is negative 2x minus 40? Why? No pun intended. Well, in order to move the 2x over, you subtract it from both sides. And in order to move the 40 over, you also do that. Well, we're pretty close. Thing is, we have a 3y. We just want y. Well, what we can do is divide everybody by 3. And then we get negative 2/3 x minus 40/3. Honestly, this is how I would leave my answer. I like improper fractions. But we still haven't answered the question. The question was, what's our slope and what's our y-intercept? Well, now that we have our line solved for y, we're like, yes, we can read it off. What is our slope? The slope is negative 2/3. And our y-intercept is negative 40/3. So I would write that as 0, negative 40/3. If you wrote negative 40 over 3 on a test, I would be okay with that. I like to write it as an ordered pair though. Okay, let's do a couple more. What if I gave you this and asked you to find the formula for the line? Okay. Let us do this. Suppose the information we're given is, let's just do this. A year t and the value of, I don't know, a computer. We'll call that V. And let's just say we have 0, 1, and 2. And we have 2,000, 1,500, and 1,000. Okay. What we're saying is, in a particular year, so year 0, that means initially when we got the computer, the value of it was $2,000. 1 year later, it depreciated to $1,500. 2 years later, it was down to $1,000. Okay? Now, you could do this a few different ways when you're given a table. In this table, I claim we can already read off our y-intercept and we can automatically read off our slope. Okay? Let me show you that. And then if you don't really identify with it that way, I'll show you how to set this up and find the equation given what we had. Okay? Remember, to find the equation of a line, these are the two guys you need. Okay? Your m is your rate of change. Okay? So, what's our rate of change? Well, don't we decrease by 500 for every year? Right? This goes down by 500, that goes down by 500. So we would say negative 500x. And remember, your b is your value when your x value, or in this case, t is 0. That's our initial price. And this is how much it goes down by. Okay? Now, if you didn't put that together, do not worry. That comes with time. But let's just take these ordered pairs. Let's pretend we're like, oh, I just want to do it the way we always do it, Lauren. Let's write out 2 ordered pairs and find it. We can certainly do that. Okay? If you're given 2 points, you can find the equation of a line. Now again, let me repeat, you don't have to do it both ways. I just want to show you that no matter which way you do it, it's okay. So our slope is the change in our y values over the change in our x values. Notice you get negative 500 over 1, which is negative 500. We would be concerned if we didn't. Okay? Now, to find the equation of our line, we can plug in we can do it as y equals mx plus b. So don't we already have this? We found our m. And now what we can do is take one of our ordered pairs and plug it in here. I'll take this guy. Y is 1500 when x is 0. Or excuse me, when x is 1. So I get 1500 is negative 500 plus b. To solve for b, we would add 500 to both sides. And lo and behold, you get 2000. So you get the exact same equation. Okay, let's take this. If we're given a graph, let's pretend we have this line, and we're given that this is 60, this is 5, and this is 144, and that's up at 12. Not drawn to scale. Well, how would we do this guy? Well, same way. Again, in order to find the equation of a line, you need 2 points. We have 2 points. We have the ordered pair 60, 5, and we also have the ordered pair 144, 12. And we would proceed in the exact same manner. First, find our slope. 12 minus 5 over 144 minus 60. You with me this far? All right. So what is 12 minus 5? That's 7, and I'm going to be lazy about life right now. And I get over 84. Cool thing is, 7 does go into 84 12 times. So we could write that as 1/12. All right, we got our m. So now, let's find the equation of our line. Just to be different, let's use the y minus y1 equals m times x minus x1. If you prefer the y equals mx plus b, you can ignore me during this portion, and you will see that you're going to get the same solution that I am. Okay, again, it doesn't matter which ordered pair we use. I'm going to use the 60 and the 5. So I take y minus my y value is m, which is 1/12, times x minus my x value. So I get y minus 5. If I distribute my 1/12, I get 1/12 x. 60 over 12 is 5. Oh, this is so cute. Now to get y alone, we add 5 to both sides, so we just get 1/12 x. That was fun. Okay, let us do a word problem. I'm going to look at 52 in the book. And what this says is, in a college meal plan, you pay a membership fee, then all your meals are at a fixed price per meal. It says that 90 meals cost $1,005, and 140 meals cost $1,205. And what we want to do is write a linear cost function that describes the cost of the meal plan in terms of the number of meals. Well, in order to find the equation of a line, we need two ordered pairs. I think you'll grant me that the cost is dependent upon the number of meals. Therefore, my quote-unquote X value is the number of meals, and my Y value is the cost. Can we find the equation of this line? Totally. First thing we've got to do is find our slope. Our slope is the change in the Y values over the change in the X values. So we get 200 over 50. Oh, I love it when numbers come out nice. And we get 4. All right. Now that we have that, we can find the equation of our line, again using the y minus y1 business or the y equals mx plus b. I'm going to use the y minus y1 again, and I'll just use this ordered pair. So I get y minus, 1005 is 4 times x minus 90. So I get y minus 1005 is 4x minus 360. And if I add 1005 to both sides, I get y is 4x plus 645. Now that's fine and dandy, but even more interesting is to interpret what does our slope mean and what does our y-intercept mean. Okay? What does our slope stand for? Well, remember, the slope is the change in y values, in other words, the change in cost, over the change in x values, the change in the number of meals. So what this tells us is for each additional meal, we have an increased cost of $4. In other words, it costs $4 a meal. What is this 645? Isn't that our y-intercept? And our y-intercept, by definition, is the value of y. In other words, it's our cost when we eat no meals. That, reading back to the beginning of the problem, is our membership cost. In other words, once we pay this whopping $645, it will then cost us $4 a meal. They better be good meals. Okay. So, should we do something with this line? Yeah, let's do something with this line. Let me just ask you this. How much will 120 meals cost? Well, what are we given? Are we given our x value or our y value? I guess to be precise, we could rewrite this as c is 4m. But that would kind of mess us up, right? Because usually we think of m as our slope, but here it represents the number of meals. To compute this, all you would do is plug 120 in for the number of meals. So you get, what, 480 plus 645? So $1,125. Okay, let me talk now about parallel, or let's do horizontal and vertical lines first. Hopefully you recall from our last conversation, if you will, that when you have a horizontal line, your slope is 0. Okay? So what if I wanted us to find the equation of the horizontal line that passes through, doesn't really matter, how about 1, 2? Well, I could say y minus my y value is m times x minus my x value. What happens to the right side of our equation? It becomes 0, right? 0 times anything is 0. So we just get y equals 2. Notice, it's the same as what that y value is. Let me show you why it makes sense that we actually got a line, a horizontal line, that has no mention of x in it, but it has y constantly being 2. Well, if it goes through the point 1, 2, and it's a horizontal line, we got the equation y equals 2. Why does this make sense? Well, notice, no matter where we are on this line, our x values are changing like crazy, but our y is constantly 2. Okay? Next. What if now I wanted us to find the equation of the line that passes through, oh, it doesn't really matter, 1, 2, and 1, negative 3. Okay, well, we need to find the slope. Slope is the change in y values over the change in x values. Notice we get negative 5 over 0, and hopefully you recall that that's undefined. Okay, we talked about what a line with an undefined slope looks like, and I claim if you plotted these points, you would see that we have a vertical line passing through 1. So it's reasonable to ask, well, what's the equation of the line? That's what we wanted to do. Well, what is it? We could, do the whole y minus y1 business. We could say it's y minus 2. We got undefined for our slope times x minus 1. But now we run into problems. Okay, right? We have y minus 2, but how do we distribute undefined? I mean, is it undefined x? Huh? Mathematically, we can't really grapple with this. So let's ask ourselves, what could our equation be? Well, whenever you're in a new situation, you want to ask yourself, what did you do in a similar situation? Our similar situation was here when we had a horizontal line. Notice our x values changed like crazy, but y was always 2. What is true no matter where we are on that line? Now our y values are changing like crazy, but isn't x always equal to 1? So let me write these generalizations out. The equation of any horizontal line passing through a point AB. You don't have to do any work if you recognize it's a horizontal line. It's just y equals whatever the y value is. And in a similar manner, the equation of any vertical line passing through the same ordered pair AB is always x equals the x value. Okay, 2 more ideas. These lines are parallel. They occur in different places in space, but parallel lines have the same slope. So if you know the slope of a line, you know the slope of every single line that's parallel to it. On the other hand, we have things called perpendicular lines, okay? Yes, lines can intersect in infinitely many ways. However, perpendicular lines are specifically lines that intersect at a 90-degree angle. So these are called perpendicular lines. Clearly, they do not have the same slope, if for no other reason than the slope of this line here is positive and the slope of this line here is negative. Okay? Formally put, perpendicular lines have slopes that are opposite reciprocals of each other. Now, I like to look at things pragmatically, okay? So the way I would tell you to look at it is if you know the slope of a line, in order to find the slope of the line perpendicular to it, what you do is you change the sign. That's what opposite means. And then you flip it. Not the most mathematically precise way to put it, but it works. So, just to practice a couple, for example, if my line has a slope of 2/3, this is the symbol for perpendicular. Don't worry about that too much. Okay, to find the slope of the line perpendicular to it, you change the sign and then you flip it. So you get -3/2. If my line has a slope of, say, 4, or let's do -4, well, the slope of the line perpendicular to it would be +1/4. Okay? So let us go through one example here. What if I wanted us to find the equation of the line, and how about, let's find the equation of the line passing through, how about 2, -3, that's perpendicular to the line. How about y equals 2/5 x plus 17? All right. Now remember, in order to find the equation of a line, we either need 2 points or we need a point and a slope. I claim we totally have a point. We know that it goes through 2, -3. Do we have a slope? Well, not directly, okay? We know the slope of this line is 2/5, but the line that we're looking for is perpendicular to it. Therefore, we can get the slope of the line we're interested in. How? You change the sign and you flip it. And now we can do this. If you want, we can even use y equals mx plus b. Y equals -5/2 x plus b, right? I plugged my m in, and now I can plug in my ordered pair. Y is -3 when x is 2. I purposefully made the numbers nice. So I get negative 3. Well, those 2's cancel as negative 5 plus b. Add 5 to both sides, and we get b to be 2. So the equation of our line is y is negative 5/2 x plus 2. Isn't that cool? All right, let's just do one more example just to be sure we're okay. And then we'll call it good. All right. Might as well do a parallel one, even though perpendicular is more interesting. Oh, this is cute. Let's find the equation of the line passing through who cares? Let's be really nice to ourselves. 0, 6. Why is that really nice? Notice it's our y-intercept. Yes! You want to identify that if you can. If you didn't catch it, don't worry about it. But we want to make it parallel to this line. 3x plus 5y equals 6. I had to put one little twist in it. Okay? Now, on one hand, this is easier because it's parallel. You agree once you have the slope of a line, you know the slope of any line parallel to it. It's the same thing. Okay? What's my twist? Well, parallel lines have the same slope, but notice this is not written in a very nice form. Okay? We like this written as y equals something because then we can just read off the slope. So the little bit of work that we have is to isolate our y here. Okay? Well, let's do that. First, we would subtract 3x from both sides. So I get 5y is negative 3x plus 6. Now to get y all by his lonesome, we would divide everybody by 5, and we get negative 3/5 x plus 6/5. Now we can read off our slope. The slope of this line is negative 3/5. And since that's the line that we're actually, well, the slope of the line that we're wanting to find is parallel to this, this gives us that slope as well. Total side note, if we were looking for the line perpendicular to it, my slope would be a positive 5/3. Again, that's a total side note. But check this out. Okay? If you didn't recognize this was the y-intercept, you could go through the y equals mx plus b or the y minus y1 equals m times x minus x1. But we have our m, we have our b, we got it. Y is negative 3/5 x plus 6. And that is it for this section. Thank you.